Today's lesson is on perpendiculars and bisectors. First definition, equidistant, which is a point whose distance from two lines is the same. Equidistant, equal distance. Perpendicular bisector, we're looking at a segment. We're going to take that segment, we're going to split it at its midpoint, and we're going to make it perpendicular. Angle bisector, we're taking an angle and we're cutting it into two equal angle measures, or two congruent angles. Perpendicular bisector theorem, any point on a perpendicular bisector will be equidistant to the endpoints of that segment, no matter where that point C is. It can be as close to point P, the midpoint there, or as far away as possible. It will always be equidistant to the endpoints of that segment. Your angle bisector theorem, any point on the angle bisector will be equidistant to the sides of that angle, as long as those segments are perpendicular. A few examples. First example, find the value of x. In this picture, A is going to be the midpoint of CD. AB is a perpendicular bisector, which means AC is congruent to AD, x equals 6. Find the value of y. B is also on the perpendicular bisector, so it's equidistant to the endpoints. Therefore, y equals 9. E is not on the perpendicular bisector because 15 is not the same as 14, so E is not equidistant to the endpoints. A few more examples. Find the length of EG. EG is going to equal 6 because E is on this angle bisector, so it's equidistant to the sides. Angle GDE is going to equal 40 degrees. We know that because we can see ED is the angle bisector. Segment ED is going to equal 10. We can tell that E is on the perpendicular bisector, EH, so it's going to be equidistant from the endpoints FD. HD is going to equal the square root of 73. H is also on the perpendicular bisector, which means FH and DH are going to be congruent. And finally, FD will equal 16. G is the midpoint of FD. GD is 8. FG 8 plus GD 8 gives us 16.